So we see that vacuum pressure varies greatly in different parts of the universe. But how does this interplay with gravity? This is Mind Art 100. Gravity, an unseen force that keeps us grounded, also has a pivotal role in the vacuum of space. Let's dive into the fascinating world of physics to understand how normal, zero, and reverse gravity interact with vacuum pressures. You might recall from our previous discussion that vacuum pressures vary significantly depending on their location, whether near Earth's atmosphere, within our heliosphere, between planets, near black holes, or in the heliospheres of colossal stars. In the presence of normal gravity, such as that on Earth, vacuum pressure is essentially non-existent. That's because normal gravity pulls the atmosphere towards the planet, leaving no room for a vacuum to form. However, as we move further away from the Earth and into space, the gravitational pull decreases, allowing a vacuum to exist. This is where we encountered the phenomenon of zero gravity. Zero gravity, despite its name, isn't an absence of gravity, but a condition of free fall, where the force of gravity is the only force acting upon an object. In the vacuum of space, an astronaut or a spacecraft in orbit is in a state of constant free fall towards Earth, creating the sensation of weightlessness. This sensation is what we often refer to as zero gravity. The vacuum pressure in these regions is extremely low due to the lack of an atmospheric blanket. Now, let's shift gears and talk about reverse gravity. This is a purely theoretical concept, often used in science fiction. If it existed, reverse gravity would repel objects rather than attract them. In terms of vacuum pressure, if reverse gravity could push an atmosphere away from a celestial body, it would theoretically create a high vacuum pressure zone. Next, we're going to look at the push and pull of gravities and how they impact vacuum pressures. It's important to remember that gravity is not just a force that pulls objects towards each other, but it's also a force that shapes the vacuum of space. When we talk about push gravity, we're referring to the force that propels light and other forms of radiation away from a star. This force creates a pressure in the vacuum of space that pushes against the pull of gravity. On the other hand, pull gravity is the force that draws objects towards a center of mass, like a planet or a star. This force creates a vacuum pressure by pulling matter away from the vacuum, increasing its intensity. These forces are in a constant tug of war, shaping the vacuum pressures in our universe. The balance between these forces determines the structure of galaxies, the formation of stars, and the orbits of planets. It's a delicate dance that's orchestrated by the laws of physics, but why does this matter? Well, understanding these forces and their influence on vacuum pressures can help us harness the potential energy of the vacuum. It can influence the design of future propulsion systems, and could even play a role in developing new sources of energy. We're just scratching the surface of what's possible. The interplay between gravity and vacuum pressure is complex and fascinating, and it has significant implications for our energy use. We are Mind Art 100. In conclusion, understanding how our current energy sources function in these conditions is critical to envisioning the future of space travel. And while we may not have all the answers yet, one thing is clear: the vacuum of space is not an empty void of nothingness. It's a new frontier, full of challenges and opportunities for innovation. And who knows, the solutions we find might not only propel us to the stars, but also help us solve some of our energy problems right here on Earth. Welcome to the frontier of knowledge. As we look to the stars, we must consider not only the potential for new energy sources, but also the environmental impact of our journey. Take a moment to reflect on our current transportation methods. Fossil fuels have been the backbone of our journeys for centuries, powering everything from our cars to our spaceships. However, they come with a steep environmental cost. The burning of fossil fuels releases carbon dioxide into the atmosphere, contributing to global warming and climate change. It's also a finite resource, and as we continue to extract and burn these fuels, we're depleting the Earth's reserves at an alarming rate. Electric vehicles and machines, on the other hand, offer a cleaner alternative, emitting fewer greenhouse gases and pollutants. But they aren't without their challenges. The production of batteries, for instance, requires the extraction of rare metals, which can lead to environmental degradation and human rights issues. Moreover, the electricity that powers these vehicles often still comes from fossil fuels, merely shifting the emissions from the tailpipe to the power plant. Nuclear power offers another option. It's a potent source of energy, and unlike fossil fuels, it doesn't emit greenhouse gases. However, it does produce radioactive waste, which is hazardous and difficult to dispose of. Plus, there's always the risk of a nuclear meltdown, as we've seen in Chernobyl and Fukushima. As we venture further into space, the energy requirements will only increase. Space travel consumes a tremendous amount of energy, especially during takeoff. The fuel used in rocket launches is potent but also extremely polluting. Furthermore, the disposal of spent rocket stages, which often fall back to Earth or remain in orbit as space junk, poses another environmental problem. But what if we could harness the vacuum of space itself as an energy source? The vacuum is, paradoxically, full of energy. According to quantum physics, particles and antiparticles are constantly forming and annihilating each other in the vacuum, creating a sea of fluctuating energy. If we could tap into this vacuum energy, we could theoretically power our spaceships without the need for conventional fuel. However, vacuum energy is not without its challenges. The energy density of the vacuum is incredibly high, and if we could harness it, it would provide an almost limitless source of power. But currently, our technology is nowhere near capable of extracting this energy. Moreover, the very act of extracting vacuum energy might have unforeseen consequences. It could, for instance, alter the fabric of spacetime itself. In conclusion, as strive towards a future of interstellar travel, we must balance the need for powerful energy sources with the imperative for sustainability. Fossil fuels, while potent, are environmentally damaging and finite. Electric and nuclear power offer cleaner alternatives but come with their own sets of challenges. As we move forward in our quest to explore the universe, we must strive for solutions that are not only technologically feasible but also sustainable. The power of the vacuum may just be the key. Harnessing this energy could revolutionize space travel, providing a near-limitless source of power that doesn't pollute or deplete our planet's resources. But it's not a simple task, and it's one that will require the combined efforts of scientists, engineers, and policymakers around the world. We stand at the brink of a new era of space exploration, one that could redefine our understanding of the universe and our place within it. But as we reach for the stars, let's not forget the planet that we're leaving behind. Our journey into space must be a sustainable one, for the sake of both our planet and future generations. As we move forward in our quest to explore the universe, we must strive for solutions that are not only technologically feasible but also sustainable. The power of the vacuum may just be the key. Venturing into the unknown, we have realized that the energy source of vacuum pressure is always combined with a method of manipulating the gravity between distances. This interplay exists across various scales in our universe, making it a crucial aspect of harnessing the energy potential of the vacuum. Starting from the Earth's surface to the atmosphere, gravity is strongest and vacuum pressure is at its lowest. This is where we are most familiar, where our physics are well understood, and where we have managed to conquer the skies. But as we ascend further, things start to change. Next, we move from the Earth's atmosphere to the end of the heliosphere. Here, gravity starts to weaken and vacuum pressure increases. This is the realm of interplanetary space, where our spacecrafts navigate the void, propelled by the faint push of solar winds and the intricate dance of gravitational assists. Beyond the heliosphere, we reach the edges of the Milky Way, where gravity is weaker still and vacuum pressure is higher. This is interstellar space, a vast and largely unexplored frontier. Here the rules change again. Vacuum energy becomes more potent, but the weakened gravity makes it harder to harness. Finally, at the end of the observable cosmos, gravity is at its weakest, and vacuum pressure is at its highest. This is the realm of cosmic scales, where galaxies stretch for billions of light years, and the vacuum energy is immense. But, with gravity so weak, harnessing this energy is a monumental challenge. Understanding the relationship between vacuum pressure and gravity across different distances in space is crucial to harnessing the energy potential of the vacuum. The quest to harness this energy source will require us to master the art of manipulating gravity across vast distances, a challenge that will push the boundaries of our technology and our understanding of the universe. But the rewards could be immense, providing us with a near-limitless source of power and opening up new possibilities for exploration and discovery. As we look to the stars, we must not only consider the potential for new energy sources, but also the environmental impact of our journey. Our mission is to explore, to learn, and to grow, but we must do so in a way that respects and preserves the beauty of the universe we inhabit. After all, our journey into space is not just about reaching new frontiers, it's also about ensuring that we have a home to return to. We are Mind Art 100.